This is my second video on writing radical expressions in simplest form, except for in my first video we only used numerical values on the inside of these radicals in the radicand, okay? In this video we're going to be utilizing, variable expressions. So this is really pretty much the same process that we went through. We just want to remind ourselves that for a radical to be in simplest form, we said we not only apply the properties of radicals, but we also remove any perfect nth powers that are on the inside. So for instance, on this first one here, we say it's a cube root. We want to get anything that's a perfect cube out. And then also this, we need to rationalize any denominators. So if we were to be left with anything like, I don't know, 2 over the 5th root of, 7, we couldn't leave that radical in the basement. So let's go ahead and take a look at some of these expressions that I've set aside for us here. And I look at this first one, and what I'm going to do is I'm going to make a recommendation to everybody. When you are simplifying radicals, if there are any numerical values on the inside, the first thing we want to do is we want to write the prime factorization for it. That is, we want to break this sucker down as far as we can break it down, and we want to write it as a product of prime numbers together. So if I'm going to re-scribble this one, essentially, what I'm going to do is I'm going to say that this is really the cube root of 5. We had 3 5s, so we say 5 cubed, and then we have y to the 6. Now, rewriting this, what I'm trying to do is I'm trying to remove perfect cubes out of here. So I notice that 5 cubed, now that's 125, which is a perfect cube of 5. But we're saying, how many groups of 3 5s, or how many groups of this many 5s can you make me out of this? And I say, well, I could make you one group of 3 5s. So in terms of, what's left on the inside of this, we say, well, I've got my cube root, but I'm taking one group of 5s out, and that would leave me behind with no 5s on the inside. I'm going to write 5 to 0 just for now. And then we say, well, y to the 6, how many groups of 3 can you make me here? Well, I can make you 2 groups of 3. So then we take out 2 groups of 3 y's, and we say, well, 2 groups of 3 is 6, and if I took all 6 y's out, then I've got none left on the inside. So really what we get here is we get 5y squared, and the reasoning behind that is because these are both 1, and the square root of 1 is 1. And actually the cube root of 1 is what we're talking about. So the cube root of 1 is 1, and anything times 1 is itself. So the idea here is this. We were able to take out 2 perfect cubes out of this, and these perfect cubes were 5 and y squared. And if you cube those, you can see how you get back your 125y to the 6. So let's take a look now at this next expression. Now, one thing I do want to say about this is if we'd like to, we could certainly interpret this as, instead of a rational exponent, we could interpret this as this is the square root of, 9 u squared v to the 10th. And if we were to treat this the same way we did on the last one, we say our index is 2. We say the prime factorization of 9 is 3 to the 2nd. We have u to the 2nd. We have v to the 10th. But again, we're asking how many groups of 2 can you make me? So we say, well, 3 to the 2nd. And I'm putting them into groups of this size. So I can make you one group of 3's here. And we say left on the inside, I wouldn't have any 3's left. Okay, so I'm not going to write anything left on the inside there for the 3's. We say, well, u to the 2nd, I can make one group of 2 u's. And then v to the 10th, well, how many groups of 2 could you make me there? Well, I can make 5 groups of 2. So we say 5. And then we say there would be nothing left on the inside throughout this entire thing. So we really got 3u v to the 5th is the square root of 9u squared v to the 10th. Okay, and we could of course check to see that squaring this gets us back to the original, but that's how we might work through this. And another way to work through this, again, we could have used properties of exponents here that said, well, this would be 9 to the 1/2. U to the 2 times a half is 1, and v to the 10 times a half is 10 times a half is 5. So we really get this, which is still the square root of 9 u v to the 5th. Okay, so it was what we got. So let's take a look at this one here. Now, a little bit different. We need to split this up to begin with. So we say the 4th root of x to the 4th, and the 4th root, it looks like, of y to the 8th. Okay, and so we say, do I have any coefficients in here? No coefficients, so I don't need to factor anything. And now we're just taking out groups of 4. So I could take out one group of 4x's up here, and I could take out 2 groups of 4y's apiece down here, and you'll notice that you wouldn't have anything left over on the inside. So this would just be x over y squared. And then last but not least, we've got this doozy right here. Okay, so now first thing I want to do is I actually want to simplify this expression. Okay, so using our properties of exponents, let's start with this. We say 6 divided by 2, that would be 3. If we had x to the first power over x to the 1/3 power, is going to be x to the 1 minus 1/3 power. So 1 minus 1/3 is x to the 2/3. So we get now 3x to the 2/3. Now we'll do our y to the 1/2 over no y's down here. So this just stays y to the 1/2. And then we'd say, okay, so I've got z. This is technically z to the 0 over z to the -5 here. So the interesting thing is this. When you take z to the 0 minus a -5, you get z to the 5th. Okay, which really means just that this z down here is going to move up top, and I get z to the 5th. So now simplifying this expression was basically what we just got done doing here, and I just want to show that we have a simplified expression. If I were to rewrite this in radical notation, okay, we have x squared, the cube root of that, so 3 times the cube root of x squared times the, looks like we have the square root of y to the first, times the z to the 5 over 1, which is really, it's not even a root. So the thing here is this: we have no perfect cube roots in here, no perfect square roots in here, and we have no radicals in the basement. So this would be a perfectly okay thing to end with in a simplified form. Actually, we'd write it this way just to be clear. Cheers.